Next, let us talk about events which are happening independent of each other. Meaning, let's say talk about two events which are independent of each other, or the random events. So we can talk about random events or independent events. Let's go back to earlier example and let's consider a box. Okay, now again we'll talk about, okay, earlier considered two regions. Okay, so region A, or so to say here delta V1 earlier we considered and delta V2 earlier considered. Now in earlier case we had talked about only particle, only one particle. Okay, but now let's talk about a particle 1 and take another particle 2. Okay, so let's say the probability of finding the particle in event in the region delta V1, let's say I had to again n trials. Okay, so the event A that I am defining now, the probability of the finding the particle in, so event A, finding the particle in region delta V1. So event B for me is what? Now find the particle 1. Okay, so event B, which has to be the independent of this, so I am defining another event, finding the particle now 2 in delta V2. So now see the cases here. Okay, so I am considering here the event 1, finding the particle in this. So let's say I do n number of trials, so the probability, and I find m number of times. So m number of times I find the particle in delta V region. Okay, so m number of times in delta V. Okay, so the probability of finding the particle, so P1 is my probability of finding the particle 1 in delta V1 will be given by N1. Okay. Similarly, I do N trials now, event B, where there are N number of ways. Let's say again I do N trials. Okay, N trials. In that case, n number of ways I find the particle, this particle 2 in, let's say, delta V2. Now see, particle 2 is not concerned about whether particle 1 is in delta V or not. Irrespective of that event, particle 2 can be in this delta V2 region or not. Okay, do these two events that are occurring, these are independent of each other. So the probability or the occurrence of one event is not disturbing or not affecting the occurrence of the other event. So meaning both the events are independent of each other. In that case, what is the probability of finding the particle 1 and 2, okay, at the same time, same instant, in, let's say, particle 1 is going to delta V1, 2 is going to delta V2. What is the probability of happening both the event jointly at the same instant? So the probability of finding the particle 1 in delta V1 and delta V2. So see, we are writing, so the probability of finding the particle 1, there is a probability of occurrence of event 1 and B at same instant. What is the probability? So in that case, so as I say, the probability of happening this event B, where finding the particle 2 in delta V2, in that case it is P2, which was equal to n by n, because total number of trial was n. So in that case, the probability of finding the particle 1 in delta V1 and particle 2 in delta V2 region at the same instant, okay, this is important, at same instant will be P1 multiplied by P2. So at same instant. So that's very I'm talking about at the same time both the events are okay. What is the probability of finding? So in that case it will be simply multiplication of both. So let's look at one of the example. So here let us throw a die twice. So I take a die and throw it twice and obtain two numbers. Of course we will get two numbers if I throw the dice, throw a die two times. Okay, what is the probability that these numbers are 6 and 4? Okay, so we know that if we, so we are specifically asking what is the probability that the first number is 6 and the second number is 4. Okay, so now the occurrence of 6 is independent of what happens in the second, or the occurrence of second number is independent of what has happened in the first case. So the probability of finding in the first case 6 is given by 1 by 6, and the probability of the second time when I throw the die, and in that case the probability of occurrence of 4 in that case will be 6. So the what is the probability that these numbers are 6 and, so I need probability of the joint probability where number 6 in first case and 4 in the second case. So it will be simply multiplication of both the probabilities, and that will be given by 1 by 36. Now let us move on and discuss about conditional probability. Now let's consider two events. I just simply name it event A and event B. Okay. So I don't know what these two events are, but simply consider event A and B. So in conditional probability, let's say, so here these two events happens one after the other. Okay, so here the event that we are considering A and B, these are, so one precedes the other. Okay, so now we are interested in, let's say event B has occurred first. Okay, and then we are interested in what is the probability of happening occurrence of the event A with the condition that event B has occurred. So it is written like this: what is the probability of A given the condition that B event has occurred? So that is conditional probability. Okay, so here, okay, so the basic idea behind is that, so this way I represent this, the probability of occurrence of event A with the condition that event B has occurred. So best way to understand this conditional probability is with an example. Okay, so let's consider one example. So let's say a box which contains 4 black and 3 white balls. What is the probability that on 2 successive draws, so we have taken out 2 balls from the box. Okay, the balls drawn are both black. Okay, so there are how many black balls are there? There are 4 black balls and white are 3. So we need to find out, so we have drawn two balls one after the other, and what is the probability that both the balls are black. So now the first event, let's say the event B which has occurred, so we have the event B precedes, it happens first, then event, according to our definition that we have discussed in the last slide. Okay, so event B is the occurrence of, so there are 4 black balls, right? So total number of balls in the box is 7. So probability of occurrence of the event B, which we call the getting black ball, is 4 by 7. Okay, so now we are interested in what is the probability of A having occurred the B. So probability A is what? Getting black ball again. So we have already taken out 1 black ball. So we will be left out with 3 black balls. Okay, so now in the second case we will have only 3 black balls. So after the first event, white will be all 3 of them are there. So total number of balls will be now 6 of them. Okay, so the probability of getting the black ball in the second time, or with the condition that event B has occurred, will be simply 3 by 6, or getting half. So here the first event has a effect on the second event. Okay, so this is about conditional probability. Then we'll talk about another very important topic or important information that you need to know about this permutation and combinations. So basically the permutation means arrangement of the objects. Okay, combination means grouping. Okay, now let's say there are 4 objects A, B, C, okay, which are distinguishable object, and as I named A, B, C. So I take 2 at a time. Okay, I can take A and B first, A and C, B and C, whichever way. So I want to arrange them. So there are 3 total objects. So I take 2 at a time and try to arrange in a different meaningful ways. Okay, so I can arrange them as A, B. I can arrange them as B, A. Is a different arrangement, right? So I can arrange them as AC, CA, and BC and BA. So there are 6 ways that I can arrange the 3 objects, 3 distinguishable objects if I take 2 at a time. There are 6 ways, 6 meaningful ways I can arrange them. Okay, so this is called as permutations. So the formula to obtain how many ways I can arrange these 3 distinguishable objects is that it is 3p2. So which is given as, this is a p is permutation. So 3 factorial by, it will be 3 minus 2 factorial, which will be equal to, we know that this is 6. So basically if there are n numbers of object, total number of n object, and there are number of ways I need to arrange, or if there are n number of objects and if I take r number of objects at a time, so how many ways I can arrange this n number of particles or n number of objects in taking r at a time will be given by simply n factorial, n minus r factorial. Okay, in the combination case, so again let's say I have A, B, C, 3 distinguishable objects. Again I take 2 at a time. So here I am doing grouping. I am not concerned about how these particles or the objects are arranged within the group. So meaning I can, this A, B and B, A, they are in the same group. So so B, A is not giving any extra meaning. Okay, so the meaningful ways I can group these 3 objects, if I take 2 at a time, is AB one way, I can group it BC, I can group it 3. So I have only 3 meaningful combination, or the 3 meaningful groupings, or 3 meaningful ways I can group these 3 objects if I take 2 at a time. So the formula to obtain how many ways I can combine them or group them is given by, in this case, 3C2. Okay, so as you all know, this is 3 factorial by, so r factorial, also meaning 2 factorial, and 3 minus 2, 1 factorial. So this is given, this is, as you all know, this will be 3. The general formula to get it, if there are n number of objects and if I have to form grouping taking r at a time, how many ways I can combine this n number of objects if I take r at a time will be given by n factorial by r factorial divided by r factorial n minus r factorial. So these are the 2 formulae which are very important to remember or know. So this is known as permutation.